In this video lecture, I will be talking a few more examples with linear equations in topic 4. So first, we look at the following example. 4. Solve the initial value problem. Recall that an initial value problem has two parts. The first one is the ODE, a differential equation. In this example, we have minus x y prime equals to 5y minus 6x with x positive. This is the ODE, and the extra condition x positive is to restrict our independent variable x to be positive only. So we don't deal with independent variable x negative. And then we have the initial condition y1 equal to -1. And we need to recognize this initial condition actually means that when x equal to 1, y equal to -1. That the initial condition, and the above is the ODE. So we solve the ODE first by rewriting the equation, by rewriting this equation here into the correct form. So as always, what we could do first is to compute y prime by dividing through, in this case, by dividing through everything by negative x. So we will have 5y over negative x, and then minus 6x over negative x. And simplify this, we will have, let's rewrite the coefficient in front, and then we cancel the second factor. We have plus 6. And then everything, so now let's look at this. We have learned two types of differential equations: separable equation and linear equation. Now for some problem, you need to try to recognize whether you have a separable equation or a linear equation. So to see whether it's a separable equation, we need to try to factor the left-hand side. But in this case, there's nothing to factor, and we don't have any common factor to do so. So the equation is not separable. So let's check whether it fit the format of the linear equation. So to do that, we need to rewrite the derivative first, and then we have to move this term to the other side to get plus 5 over x y, and then everything else without y or derivatives on the right hand side. So it does fit the linear equation. So let me recall the format. Actually, this is the format for standard linear equation. Is that we have y prime plus px y equal to qx. And it does fit this format here. And here we have px is 5 over x, and qx is 6. So to make sure that to fit the linear equation, the coefficient here should be in x only, and the same thing here should be in x only. There's no y in these coefficients. So once we have identified px and qx, we can write out the integrating factor, which is mu e integral of px, which is phi over x dx. So we have e, and then integral phi over x is 5 natural log of absolute value of x. Again, we don't put a constant here at this time. Well, x is positive. That's the assumption on the independent variable. So we don't really need the absolute value. We just have log of x. But how do we simplify this? Now, whenever you have exponential e raised to something with natural log, you have to simplify it to make it simpler. How do we do that? Well, the constant 5 in front here, we can bring in exponent because that's the rule of logarithm, right? So mu, I should have written mu of x, mu of x. So we have e to the log of x to the fifth. That's the rule of logarithm and exponent. And then we have e raised to the log. We can cancel out to get x to the fifth. So you see, after using some algebra, we have simplified the integrating factor to a very simple format, x to the fifth. So once we have that, we will multiply the standard form of the equation, which we had earlier. And we need to multiply through by the integrating factor x to the fifth. And then we get this is the standard form. Multiply through by x to the fifth. So we have x to the fifth y prime plus x to the fifth over here, 5 over x y, and then don't forget on the right hand side we also have x to the fifth 6. You don't need to simplify the left hand side, but you should know how to write immediately that the left hand side is a derivative of a product. What product is that? It's always y times the integrating factor, which is x to the fifth. And let's double check quickly why we have that. Using the product rule, for this product, we have the derivative of y, which is y prime times x to the fifth, exactly right here. And then y times the derivative of x to the fifth, which is 5x to the fourth. This exactly right here. After we simplify x, we will have 5x to the fourth. So that's good. So always check to make sure it's correct. And then 6x to the fifth here. Now we integrate. We have y x to the fifth is the integral of 6x to the fifth dx. And this is just the power rule from calculus 1. We have x to the 6. Don't forget plus c right here. So when we integrate the equation, we need to add c. But when we compute the integrating factor, there's no need to do so. Now we're going to use initial condition. Which says that x equal to 1, y equal to -1. So we plug this value in. I have -1 for y times 1 to the fifth equal to 1 to the 6 plus c. So we get -1 equal to 1 plus c. And from here, solving for c, we have c in -2. Now we plug c equal to -2 back into equation star that's over there. The goal is to solve for y, to get y equal to a function. That's our solution. So we have y x to the 5th equals x to the 6th minus 2. And by solving for y, we need to divide everything by x to the 5th. We divide x to the 5th, x to the 5th, x to the 5th. We get the answer y equal to x minus 2 of x to the 5th. This is the answer to the initial value of problem that were given at the beginning. So for this problem, the important rule from algebra is this. That's wanted to remind you. If we have e to some constant k log of x, then you need to bring the k into the power. So e log of x to the k, and we can cancel e and log to get x to the k. That's the important rule from algebra you need to know. Now, let's look at another similar example. Example 5. This time we will solve the following equation. X y prime equals to 2y plus 4x squared. Again, we have condition x positive. There is no initial condition in this problem. So we are looking for general solution. Meaning that in your solution, there will be constant c. As before, we can first divide through by x, because x is the coefficient of y prime here. To get 2 over x, y plus 4x squared over x. Then we have y prime equal to 2 over x, y plus 4x. As before, we can try to factor the left-hand side. In this case, we can factor the number 2 out, but then still we cannot factor as a separable equation. Because for separable equation, we need to factor into a factor of x times a factor of y. If we just factor 2 out, still we cannot isolate x and then y. So let's rewrite the equation in the linear format. So y prime minus 2x y equal to 4x. And this is the correct format for linear equation, which says y prime plus pxy equal to qx. always check the format to make sure that we have linear equation correctly. Later on, we will learn other type of equations, and each time we have to check whether a given equation is linear or separable or something else. So it's best to check carefully. So for this problem, what is P of x? You need to be careful. P of x is whatever coefficient in front of y. So it's include the minus as well. And if you don't include the minus, everything after this would be wrong. Important, if there's a minus sign, put that in as well. All right, so once we know P of x, we can compute integrating factor mu of x, which is e to the integral of minus 2 over x dx. And as before, we will have a minus 2 log of absolute value of x, but x is positive, given right here. So we can remove the absolute value. There's no need to write absolute value. We have e to the minus 2 log x. Now, how to simplify this? We need to bring the entire number in front here, minus 2, into the exponent to get x to the minus 2. And then we can cancel e and log to get x to the minus 2. This is the integrating factor. Once we have an integrating factor, we multiply standard form through by x to the negative 2. So let's go back to the standard form. This is the standard form here of the equation. We need to multiply through by x to the negative 2. Let's rewrite that. We have x to the negative 2 times y prime. There's a negative 2 here. And then minus x to the negative 2. We have 2 over x. Y equal to x to the negative 2 times the right hand side. Right hand side 4x. I have 4x. As before, the left hand side always derivative of the product y times the integrating factor, and then check again. Make sure it's correct, and simplify the left hand side. We get 4x to the negative 1. Now integrate y x to the negative 2 is the integral of 4x to the negative 1 dx. So what do we get for the integral here? For the antiderivative, we have 4 integral of x to the negative 1, which is the same as 1 over x. So we have log of x is positive, we don't need absolute value, plus a constancy. There is no initial condition. No initial condition given. So we need to solve for C. So next step is to solve for x. Sorry, to solve for y by doing what? By multiplying both sides by x squared, because that x to the negative 2 is nothing but x squared in the denominator. So we actually have y divided by x squared equal to 4 log x plus c. So solving for y, we get 4 square log x plus c x squared. This is the general solution to the given equation. Now, I will quickly explain another example involving trigonometric function. For the example, I won't give you the complete solution, but at least to give you the integrating factor for you to continue. We solve this equation: y prime equals to minus tangent x times y plus 1. With the condition is that x between 0 and pi with 2. X is bigger than 0 but smaller than pi with 2. This is just a restriction on the independent variable x. And we don't have any initial condition for this problem. We will see why we need such restriction and how we use it later on. So as before, we rewrite the equation as y prime plus tangent x times y equal to 1. And it's matches the linear equation, standard form of linear equation, y prime plus pxy equal to qx. Matches completely. So px in this case is tangent of x, and qx is just 1. So what is the integrating factor? Or you may pause the video here and think for yourself what it is. The formula is integral e to the integral of tangent x dx. So we have e raised to, okay, what is the integral, the antiderivative of tangent? Well, that is natural log of absolute value of secant x. Now, the condition on the independent variable says that x is between 0 and pi with 2. So then secant, which is 1 over cosine of x, is positive. And so we can skip the absolute value. We just have log of secant. And then we can cancel to get secant x. This is our integrating factor. It involves trigonometric functions. Once we have integrating factor, we can multiply through the standard form by secant of x. So go back here. The standard form of the equation is this format, and we need to multiply through by secant of x. So what we get is secant x y prime plus secant x tangent x y, and don't forget we need to multiply the left side by secant as well. Okay. On the left, originally we have 1. After multiplying by secant, we have secant. And this side is always the x of y times the integrating factor, which is secant of x. Now we have to integrate y times secant of x equal to the integral of secant x dx. So what is this? What is the integral of secant? You might need to review if you have forgotten. It's a log of secant x plus tangent x. And then don't forget plus c, y times secant. Now you can solve for y. What do we do? This is for you to think about. But well, just recall that secant is actually 1 over cosine. The answer would be like this: cosine x log of absolute value secant x plus tangent x plus c times cosine x as well, because we need to multiply through by cosine x in order to solve for y. And this is the solution to the given differential equation. This completes the video lecture for today.